A very good morning to you all.
Good morning, teacher.
How are you? Can we have some of the examples that challenged you? You can post them on the WhatsApp group, then I extract them from there. Guys, questions? Are you saying you passed all the numbers? Why you didn't do? There's also that possibility. Members never tried out any number. We are waiting for some few people so that we can kickstart at around 10:15, 9:15. But as they were coming, I'd expected people to send me their questions. And we take a look at them. Since people do not have numbers, these days are coming, if they're coming. We had introduced compound angles. Okay, another person is here. Yes, do you have any examples that you felt like were challenging? If people don't have their numbers, let me bring mine. It's 1 minute away. Okay, 2 more people have come. So here we are. Yeah, it was last time we introduced compound angles, just like you can see them down there. Those are the angles we introduced. We also saw how we can simplify such. But from these double angles, brains are here. They can ask us to prove. Want to get the exercise and look at some of the numbers. Anyone with Backhouse 1? But I also have my master in mathematics. So let's go to them. So we are dealing with what we call compound angles. Compound angles. We had said sine of A plus or minus B is defined as sine A cos B plus or minus sine B cos of A. We also saw that cos of A plus or minus B would be got from cos of A, cos of B minus or plus sine of A, sine of B. We further saw tan of A plus or minus B as equal to tan of A plus or minus tan of B, or is over 1 minus or plus tan A tan B. We also saw cot of A plus or minus B, which was 1 minus or plus tan A tan B divided by tan A plus or minus tan B. So that's the review of what we discussed last time. If we discussed that last time, we can see that we can now borrow this information and be in position to solve as many numbers concerning compound angles as possible. Let's have a look at an example here. Solve the following equations for values of theta, for values of theta, sorry, not theta, for values of x, for values of x between 0 degrees and 360 degrees. A shall get 2 sine of x is equal to cos of x plus 60. B, 3 sine of x plus 10 is equal to 4 cos of x minus 10. Okay? So when solving this, the first case we are having twice sine of x is going to be equal to cos of x, cos of 60 minus sine of x, sine of 60. You can see that you can bring the sine over this side. We shall have 2 plus cos of 6, sine 60 over sine of x is equal to cos of x, cos of 60. Therefore, you can here see that sine of 60 is 2 plus root 3 over 2, or 0.866. Then sine of x is equal to a half cos of x. When you divide, you get tan of x is equal to a half over 2 plus root 3 over 2, which is a half over 4 plus root 3, or is over 2 I can publish the 2, and finally this is 1 all over 4 plus root of 3. So x is tan arc of 1 out of 4 plus root 3. Calculator, can we get the answers? Give me the first answer. You're going to have it in mind that if all students take cocaine, when the tangent is here, the next tangent is here, which requires us to move through 180 degrees for other angles. So what is the first angle we attain? What is the first angle we attain?
$9.9.
9.9 degrees. The second angle will be 180 plus 9.9 degrees, which is x is 9.9 degrees and 189.9 degrees. And those are the only answers, because 0 to 6, 360 means 1 revolution. Yeah, it means 1 revolution. So you can screenshot that before I can take you to the second exam. We there? Okay, I hope you've taken the screenshot. So the second number says, solution to question 2. It says 3 sine of x plus 10 is equal to 4 cos of x minus 10. When you expand, you'll get 3 sine x cos of 10 plus sine of 10 cos of x is equal to 4 into brackets cos of x cos of 10 plus sine of x sine of 10. Correct the sign together, we shall have 3. There's a 3 here. 3 cos of 10 minus 4 sine of 10. Outside brackets, you have sine of x. It's going to be equal to 4 cos of 10 minus 3 sine of 10 times cos of x. When I divide both sides by cos of x, you realize that we shall lose the cos on the left and the right hand side to 1, and then we shall have tan of x is equal to 4 cos of 10 minus 3 sine of 10 divided by 3 cos of 10 minus 4 sine of 10. Then x will be equal to tan arc of the whole of that ratio of 4 cos of 10 minus 3 sine of 10 all is over 3 cos of 10 minus 4 sine of 10. Calculator, what are the answers? Because it's still a positive, the next answer we shall add on 180 from all students take cocaine. So what's the first answer? Compute and give me the answers.
Teacher,
Yes, please.
I've not understood from the third line.
Okay, where is the third line? Is this 1, 2, 3?
Yes.
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 I collected like terms of x. Okay. I took the sign to this sign. So it brought 4 sine of x, sine of 10 with a negative this way. Then this one, which had 3 cos of 10, was subtracting off 4 sine of 10. Outside, I factorized outside of x. Are we together on that one?
Yes.
Then I also collected together the cos of x. I brought this one, which has cos of x on this side, by saying 3 sine 10 cos x. When it crosses over, it becomes a negative. So it becomes negative 3 sine of 10 cos of x, but factorize out cos of x. So it becomes 4 cos of 10 minus 3 sine of 10 cos of x. Are we together?
Yes.
Then divide both sides by cos x. Right?
Yes.
Okay. I want to give another number. You get?
56.53.
56.53. We all have that? Plus 180, that is 236.53. Okay. The next numbers I want to discuss of this kind. They say express the following as a single trigonometrical function. As a single trigonometrical function. A 1/2 cos x minus √3/2 sine of x. B 1/√2 sine of x plus 1/√2 cos of x. Solution. The first one, 1/2 cos of x minus √3/2 sine of x. You should be good at the other curves we drew. Those who never drew the curves, they're in trouble. I think you'll visit my YouTube to check on those curves. Cos of 60 is 1/2. Sine of 60 is √3/2. Likewise, sine of 30 is 1/2. Cos of 30 is √3/what? I can start with 60. I will have cos 60 cos x minus sine 60 sine of x. Do you realize that this comes from the expansion of cosine, because it is cosine of 60 plus x? That is a single trigonometrical function. Or I can use 30, and I say sine of 30 cos of x minus cos of 30 sine of x, which will give me sine of 30 minus x. Yep. You are working backwards now. The other time we were expanding, but now we ask ourselves, where does the expansion come from? If you ask yourself that question, then you work backwards and get there. Okay. So, hope you're done with the screenshot. Can you try out the second one? Guys, try for me this. You try it out.
So teacher, that is the answer. You just leave it like that.
Hey, and they said express as a single trigonometrical function. So the answer is that one. Unless if the question is set in this form and they tell you, for example, it is equal to 0.5 or is equal to 1, then you first express it in this form, then you get the cos inverse or the sine inverse. But if the question has no equal sign, it's just an expression, you just express as simply as possible and you stop there. Because they say it's expressed as single trigonometrical functions. So try out the second one.
Sine 45 plus x.
Can you unmute and ask me rightly? Which answers are you asking about, Rutu?
Teacher, these ones here for like this part A and part B of these current numbers are given us.
Hey, Atika Kati, the other time we have been working forward. This time round we are working backwards. We are working backwards in a way of asking ourselves what was expanded to give us that. So to ask yourself what was expanded, first find out where do these ratios of a half and √3/2 come from. That is why I had to review this. When I reviewed that, I placed this one here. Then I placed this one there. Then I saw what exactly it was looking before. And this is an expansion, of course, by addition of the angles. So it came from cos of x plus 60. You try to expand it and see, does it go back to the same? If yes, you're on the right track. If not, you are wrong.
Okay, teacher.
Hmm?
Thank you, teacher.
You're welcome. Guys, have you seen this other option here? That also cos the negative cos of x minus 45. No, wait. It is cos 45 minus x. That one is also true. Has anyone seen that? I expected such, but no one has given me that answer. Okay, let's go to proofs. Another example. given that sine of x plus alpha is equal to 2 cos of x minus alpha, prove that tan of x, prove that tan of x is equal to 2 minus tan of alpha over 1 minus 2 tan alpha. To start with, Masse, expand for me sine of x plus alpha.
Sine of x cos cos of x.
Cos of x,
Sorry, cos of alpha
yes,
plus sine of alpha cos of x.
thank you. Do 2 expand for me cos of x minus alpha. Do 2, Leila. Expand cos of x minus alpha. Maria, can you take it up?
Cos x
Thank you.
cos alpha
Yes,
plus
very
sin
good.
x sin alpha.
Lovely. So can we collect like terms like we did in the previous examples? Like terms of cos and like terms of sine. So for example, sine of x will have cos of alpha minus 2 sine of alpha is going to be equal to twice cos of, is going to be equal to cos of x into twice cos of alpha minus sine of alpha. When I divide both sides by cos x, I'll get tan of x is equal to twice cos of alpha minus sine of alpha, all divided by cos of alpha minus twice sine of alpha. Then the whole of this divide up by cos of alpha and divide down by cos of alpha. That is what we call introducing a useful one. So we shall have twice cos alpha over cos alpha minus sine alpha over cos alpha, or is over cos alpha over cos alpha minus twice sine alpha over cos alpha. Then finally, we shall have tan of x is going to be equal to twice a minus tan of alpha, or is under 1 minus twice tan of alpha. Hashtag proof. Unless if someone has a question.
Teacher, I've not understood
Where?
from the second point.
From the second line, eh?
Yes, teacher.
This is the second line. This is the second line, right? Is that what you're saying?
Yes, teacher.
Okay, I wanted to collect the sign together of x and the cos together of x. Okay? So this is where the sign is on the right-hand side. Eh? Bring it to the sign on the left-hand side. Then this is where the cos is. Bring it to the cos on the right-hand side. Do you agree that those are supposed to be the moves?
Yes, teacher.
Now, if I move them, eh, this one is moving as 2 sine x sine alpha. When it reaches the other side, it becomes a negative. Do you agree?
Yes, teacher.
But because it's going to meet another sine x, I factor out the sine x. I remain with cos alpha here, which is that one, minus the incoming 2 sine alpha sine x. But the sine x has gone out, so this is the incoming. Do you agree?
Yes, teacher.
Then on this second one, we have 2 cos x cos alpha. Because we are merging it with another cos x sine alpha, the cos x can be factorized out to give us 2 cos alpha, that one, minus sine alpha, that one. Hence the solution. I think from there you can understand. Because after here, I divided on this side by cos of x. I divided by this side by cos of what? Then this one died, remain with 1, then it crossed over this way to give us a tan of x. Okay, can I move to the next proof? The next proof is going to be
Yes.
if you have done the exercise in Backhouse 1, there is number 20. I've forgotten the page. Let me see if I have the page. You know, I gave you those pages, but you guys don't mind a lot about visiting. Me, I told you, the only evidence I have that you guys have done numbers, if you people post numbers which have challenged you, the fact that none of you posted any number, it is conclusion to me that none of you did the numbers. And you know deep inside your heart, you're not lying to me, but you're lying to yourself. So you know deep inside there that you didn't do the numbers. If you tried 1 or 0 or negatives, and you are just there. Let me first give you this number. You hustle with it. Maybe you'll stop joking around. Before I do the number, let me first give it to you. Your number, prove. You're doing this one. Prove that. I don't say that this is how teachers teach. They teach you 1 + 1 by giving you 2 seeds of maize. Then they ask you how many seeds are on a full cone. A plus B plus C is equal to her. Will it fit? It won't fit. Let me put it here. Prove that tan A plus B plus C is equal to tan A plus tan B, a plus tan C, a minus tan A, tan B, tan C, or is over 1 minus tan A tan B, minus tan A, tan C, and minus tan B, tan C. Hence, prove that this one is yours. Punishment for not doing numbers. If A, B,